Good day, ladies and gentlemen. You are welcome to another class in chemistry. And today we are going to be looking on a topic called bonding. Bonding. Okay, so let me just tell you why bonding is important, or why elements or atoms go into bonding. You see, all atoms or all elements in the group, you see, all elements in the periodic table want to attain a stable configuration state. They want to attain an octet or duplet state. Because if you look at your periodic table, you can see that the group 8 elements, they have attained a stable electron configuration. That is the octet or duplet state. And that makes them stable. Now, other elements from group 1 to group 7 are not stable because at their outermost shell, they don't have this octet or duplet state, meaning that they are unstable. And because of this, these elements go into bonding with one another, either sharing or donating of electron in order to attain this electron stability. And today we are going to be looking at the types of bonding in which these electrons go into. And number one is the what? Is the electrovalent or ionic bonding. So the electrovalent bond or ionic bond is just simply okay. So we say that electrovalent bond deals with the transfer of electron from a metallic atom to a non-metallic atom. Note the fact that it deals with metal and non-metal. So for you to be able to identify an electrovalent or ionic bond, the compound must contain metal and non-metal. Now let's look at the processes or examples of electrovalent bonds. We have a situation of sodium coming with chlorine to give us sodium chloride. And how does this occur? You see sodium here. Let's draw a shell of our sodium. You see, this is sodium. This is the shell. This is sodium, with one valence electron plus our chlorine. Let's draw our chlorine. This is the plus. Okay. This is our chlorine. If you look at these two atoms, you can see that sodium here has just one valence electron and chlorine here has 7 valence electron. Chlorine needs 1 valence electron to complete what? 8 and to attain the octet stability. While sodium here needs to donate 1 so that it will be reduced and attain octet stability. So the both of them come together and do that. So in that process, sodium will donate its electron to this, and we will be having something like this. We'll be having something like this. When sodium is done donating, sodium will attain its octet stability. You can see it has been reduced. This is your sodium ion, sodium plus, because it has donated electron. And you look at your chlorine is this. So this is your chlorine ion, because it has accepted the electron. You can see here the number of sodium here was 11, and here was chlorine was 17, but here the number of sodium 10 and here 18, attaining octet. So this is all together, this is your sodium chloride. This is your sodium chloride. So this process is called the electrovalent or ionic what bonding, because it deals with the transfer of what electron. You can see the electron that was being transferred here. This is the transfer of electron. Let's look at another example. Another example between example 2 between magnesium chloride. Yeah, magnesium, that's Mg coming together with Cl2 to give you MgCl2. Okay, we have metal, and here we have what? Non-metal. Okay, so let's look at the case of magnesium chloride. And you know how this came about. Magnesium plus chlorine to give us magnesium chloride. Magnesium has +2 here, chlorine +1, so interchange to give you MgCl. So in this case, we are looking at magnesium. This is magnesium. This is magnesium. Magnesium having 2 valence electron, plus you have chlorine. You have 2 atoms of chlorine, because this is Cl2, meaning 2 atoms of what? Chlorine. So this is our first chlorine. Then we have another one, second chlorine, or second chlorine. So this is our magnesium. This is our first chlorine, and this is our second chlorine. Okay, Cl2 meaning 2 atoms of chlorine. So what happens? What happens here? Okay, let me just put these 2 here. Okay, all right. So what happens here? Chlorine needs 1 electron to complete 8. This chlorine needs 1 electron to complete 8. Magnesium needs to donate these 2 electrons to complete to reduce to 8 octet stability. So what will happen? This magnesium will donate to this, and the magnesium also will donate to this other chlorine. So altogether, magnesium will now be reduced to 10. Okay, so this will be magnesium 2 plus, because it donated what? 2 electrons. Then the first chlorine, this is the first chlorine, will be 18 instead of 17, because that's accepted the electron. Okay, so you have your Cl minus, then the other chlorine, the same. Cl minus. So you can see this is called what? Magnesium chloride, and you can see those electrons that we are what? Donated. Okay.